define it. Okay. So the final construct NFA constructed for this ARB whole star ABB is given here. Now we are going to see the next one, subset construction algorithm. So this will help you to convert NFA to DFA. Okay. So the main difference between NFA and DFA is NFA will have epsilon transitions, but in the case of DFA, there will not be any epsilon transition. And the second one is for any symbol from a state, there will be more than one path, right? Or more than one transition will be there. But in the case of DFA, there will be only one transition for a symbol from a given state. Okay, so to do this, we are going to check the NFA. In case if you're having epsilon, you have to remove it, right? So for this, there are three methods we are using here. One is epsilon closure that will collect all the epsilon transitions from a given state. And epsilon closure of T will help you to find out the union of all these things, right? I will tell you how to do that. And next one is the transition from a given state to the next state. Okay, so this is the algorithm for every, let us start with one set of, let us list all the set of states, okay, and let it be representing T, and everyone is having the status as unmarked, right? Now let's take the first state and then mark it. Now it is in the state marked state, right? Now we have to check from this state what are the transitions going on. So for that, for each an input symbol present in your regular expression, we have to find out what is the epsilon closure transition. Epsilon closure transition is nothing but from the state T, if you have any transition, right? Then from this state T, if you have any epsilon transition, then you have to take that state as epsilon closure of T. Okay. T is the cell state as well as the state which is having epsilon transition from this T. Okay. And we have to find it out if U is not in these states. That means if you find here U is nothing but the state which is having epsilon transition from this T. So according to this example, U is having the state yes, right? If it is not present in the state, then you have to keep that state as unmarked state, and then you can draw a transition table with stating that from this T, there is a transition on A to the state S. To the state S means here U. Okay. So likewise, you have to find all the epsilon closure, right? And in this epsilon closure of T, you have to use a stack. I will explain that example and then we will come to this algorithm. Okay, so this is the NFA already created, constructed from this regular expression. Now, let me start with first state, right? Zeroth state. First, we have to find out epsilon closure for this, right? So when you find the epsilon closure for this 0, right? This is the first state, no? So epsilon closure of 0 will be having, what are the transitions are there? 0 will be there. Next one, 1, okay? And there is a transition from 0 to 7 on epsilon, right? So that should be added here. 7. What else? 0, 1, 7 is there. Is there any transition from 0 on epsilon? Yes?
No, ma'am.
Next, what we have to do is, after finding this, we cannot stop. Again, we have to find, is there any transition from the remaining states on epsilon? So from 1, again, we are having a transition from 1 to 2 on epsilon. Okay. Similarly, there is a transition from 1 to 4 on epsilon. So these two has to be recorded. Okay. So this is also completed. So there are no more transitions from 1 on epsilon. Now let's come to 7. Is there any transition from 7 on epsilon? No. Is there any transition from 2 on epsilon? No. On F4? No. So let's complete this. 0, 1, 2, 4, 7 is epsilon closure for 0. Clear? So that's what given here. Epsilon closure of 0 is the self state, and then 1, 2, 4, 7. Let me name it as A. So this is going to be the one of the states in your DFA. Right? Let me write here. Now, as we don't have epsilon transition, this transition symbol will be having only two symbols. One is A and another one is B. Because this regular expression is over the alphabets A and B, and we don't have epsilon transition, so there is no need to create a column for epsilon for DFA. Okay. Now, what you have to do is, from this A, this is the first state in DFA, right? So that will be placed in D states array. D states is an array which is keeping all the states of DFA. So I kept A in this one, D states. Now I have to find out what is the transition from this state A to on A, on the small on the input symbol small a. Okay, so let's once again go to the previous one, right? I have to write move. This is mentioned as A now. Move A comma A. Okay, so first we have to list out all the states here present in this NFA. First, let us take 0. Is there any transition from 0 on A? No. On 1, there is no transition from 1 on A, because from 1 there are two transitions, both are on epsilon. Next 7 on A, it is going to 8. So let me take it. Okay. And 2. From 2, there is a transition to 3 on A. Okay. From 4, there is no such transition. So let's complete it here. Okay. So move A on A will give 8, 3. Clear with this? Any doubt? And we have to go and check, do we have these combinations of states in our DFA? Because in our D state, in our D states, we are having only one A, but that is having the combination of 0, 1, 2, 4, 7. But the new one is having only 3 and 8, right? Now, we are not going to stop it. We have to find epsilon closure for this 3, 8 also, right? We have to do, after finding this transition of this from these states on input symbol A, we should not stop. We have to find epsilon closure for 3, 8. So when you take epsilon closure, first we have to take the self state. From 3, there is a transition from 3 to 6 on epsilon. So 6 is the end destination state, and for this particular transition, right? And is there any other transition on epsilon from 3? No. Now when you take 6, is there a transition from 6 on epsilon? Yes, it's there. So there is a transition on epsilon from 6. So that is moving to the state 7. So that is added. Okay, right. So 3 transitions over, 6 transitions over. Now is there any other transition from 6? There is one epsilon transition. In addition to that, there is a transition from 6 to 1. So 1 has to be included. Okay, right. Any other transitions? Nothing is there. So from 6, there are 2 transitions on epsilon. One is 1 and another one is 7. Okay. So now we have to check it. Is there any transition from 7? No, there is no transition from 7. but we are having one more state here, 1. So from 1, how many transitions on epsilon? 2 transitions. One is going to 2, another one is going to 4. So 2, 4. So totally we are having 1, 2, 3, 4, 6, 7. Okay. So 1, 2, 3, 4, 6, 7. Actually 8 also we have to include it, no? I didn't copy that 8 here because we started with 3, we completed. Now we have to see is there any transition from 8. We don't have any transition from 8, so we have to just copy 8 alone as such. So you will have 8 also here. Clear? So let me once again repeat this. Once if you find the first state of DFA, from this DFA we have to find the transition on input symbol A. So we got 3 and 8, but we should not stop. We have to find epsilon closure for this 3 and 8. First I found the epsilon closure for 3. I have got 3, 6, 7, 1, 2, 4. And when you come to 8, there is no epsilon transition. So just we can copy 8 alone. Right? So totally you are having 1, 2, 3, 4, 5, 5 is not there, 6, 7, 8. Okay. So let this be a new state because we don't have any such state with such combination in any of these states present in these states. Okay, because the A is having only the combination 0, 1, 2, 4, 7. This one is another combination. So let me give a new name. So that name is B. So on A, it is moving to the state B. Okay. So we can write DFA transition from state A on input symbol A is B. Okay. Now we have to go to find the next transition, that is transition from A on input symbol B. Okay. So when you take transition move of A on input symbol B. So what is A? We are having 0, 1, 2, 4, 7 on input symbol B. Okay. So 0 on B, do you have any transition from 0 on B? No. From 1? No. From 2? No. From 4, it is moving to 5. So we can include 5 as our first transition destination state. Okay. From 7, there is only one transition A, but there is no B transition. So this is the only state. Right. Now we have to find epsilon closure for this. Okay. So epsilon closure means first we have to take 5. From 5, is there any epsilon transition? Yes. It is going to 6. From 6, it is going to 1. 1, it is going to 2. And then to 4. Okay. So 6 on input. See here, from 5, it is going to 6. From 6, it is going to 1. 1 is also and also 6 is having one more transition, 7. So let me add it here. 6 is going to 1 as well as 7, right? And then from 1, we are having 2 and 4 transition. From 2, there is no epsilon transition. From 4, there is no epsilon transition. Again, we have to find transition from 7 also. There is also no epsilon transition. So totally, you are having 1, 2, 4, 5, 6, 7. The previous states B is having 1, 2, 3, 4, 6, 7, 8. A is having 1, 2, 4, 0, 1, 2, 4, 7. But we are having one more state 5 here. So this is a different combination. So let me give the state name as C. Okay. So 1, 2, 4, 5, 6, 7 is given the name as C, and in this transition table we can write the transition from A on input symbol B is C, right? So the first state A is marked. That means we have completed these two states, these two transitions. That means the transitions on all the symbols is over from A. Now we have to from A it is moving to B, no, so that B has to be included in this D state. From A on B it is moving to C, so that C also to be included. But these two are unmarked. Now we have to go to take the first state B. Take it as marked state, right? Now once again we have to find transition from B on A symbol. Okay. Right. Now we have to take move of B comma A. Okay. B comma A is go to B. There are 0, 1, 2, 4, 7. Right? Actually, sorry. B is 1, 2, 3, 4, 6, 7, 8. Let me write it here. 1, 2, 3, 4, 6, 7, 8. From these states, we have to find transition on the input symbol A. Okay. 1 on input symbol A, no transition. 2 on input symbol A, it is going to 3. So 3. 3 on input symbol A, it's not going anywhere. 4, there is only a B transition, no A transition. 6, only epsilon transition, no A transition. 7, it is going to 8. Right. 8, there is no A transition. So 3, 8. Now, if you find epsilon closure for this 3, 8, already we have studied this one, right? Epsilon closure of 3, 8 will give you 1, 2, 3, 4, 6, 7, 8. That is same state B. So no need to do again. So let the state be B, which is the D state, right? So directly here we can mention B on A. It is moving to B. Fine. Is that clear? Any doubt? Can you understand this, students? Yes. Then number 70 present today. Number 70. Can anyone tell what is move of B comma B? Let me take all the states of B, right? From these states, we have to find B transition. Can anyone tell? Is there any transition from 1 on B? Respond please. From 1, from 2, from 3. Is there any B transition?
No, ma'am.
1, no. From B, from fourth state?
Yes, ma'am.
Yes, it's moving to 5. Right. 6, no. 7, no. From 8, it is going to 9.
No.
So we have to take epsilon closure for 5, 9. But in the previous states, we didn't come to this combination because there is a combination for 5. There is a state with only 5, but there is no with 9, right? So let me take epsilon closure for 5. 5 on epsilon closure, it is moving to 6. So let me add 5 first. On epsilon transition, it is moving to 6. Right. No other transition from 5. Now, we have to find transition from 6. 6, it is moving to 7, as well as it is moving to 1. Added. From 7, there is no epsilon transition. Okay. Next, come to 1. 1, is there any epsilon transition? Yes. 1 and 1. 2 and 4. Okay, both 2 and 4 are we are having a transition from 1 on epsilon. So let me add 2 and 4. Done. From 2 there is no epsilon transition. From 4 there is no epsilon transition. Okay, so let us complete this. So we are getting 2, 1, 2, 4, 5, 6, 7 for epsilon closure 5. But from 9 we have to find, right? From 9 there is no epsilon closure. So just we can add 9 alone, right? So we are having 1, 2, 4, 5, 6, 7, 9, right? 1, 2, 4, 5, 6, 7, 9, which is a new combination. So let's give the name as D, right? So let me write it here. B on input symbol B, it is moving to D. So we add one more state here. As we processed B, let it be in mark state. Now let's move to the next states in D states, that is C, right? So when you find C, B transition on C from C on A, it's showing epsilon closure of C comma A. So it's having 1, 2, 4, 5, 6, 7 on A, right? So it's showing epsilon closure of, we are having on 2, it is moving to 3, and from 7, it is moving to 8. So these two are having A transition. So we are having 3 comma 8. As we have already discussed, 3 comma 8 closure is equivalent to B. So we are giving this as B, right? Similarly, epsilon closure for move of C comma B. C comma B is 1, 2, 4, 5, 6, 7. On 4, there is a transition, fine. On 7, there is only A transition, no B transition. So only 5 will be there. But this epsilon closure of 5 is already we have discussed, that is C. So in this D transition, we can mention from C on input symbol A, it is moving to B. On input symbol B, it is moving to C. Now D. Okay. If you take D, 1, 2, 4, 5, 6, 7, 9, we have to take on, because there is only one change 9, but from this 9 we are having only B transition, not the, right? From 9 there is only B transition, there is only change here. So when you are taking move transition of B to on A, it won't give any changes, that will be equivalent to 1, 2, 3, 4, 6, 7 only. So 6, 7, 8 only, because there is a transition from two things which will come. One is from 2, it is moving to, from 2, it is moving to 3 on A. Similarly, from 7 on A, it is moving to 8. Okay. So these 3 comma 8 has equivalent to, the closure of 3 comma 8 is equivalent to the combination for B. So we are taking B transition of D comma A is B. But when you take B comma B, as there is a shift from transition from 9 to 10 on input symbol B, and from this 1 to 4, 5, 6, 7, 4 is having a transition to 5 on B. So 5 and 10 will come. So when you take it, 1, 2, 4, 5, 6, 7, and 10 is coming. So let us give this name as E. Okay. Again, we have to find transition for A state. Okay. So let me write it here. On input symbol A, it is moving to which state, ma? B. On input symbol A, it is moving to B, right? And on input symbol B, it is moving to E. So let me write it here as B and this one is E. Add new state E. Now find transition for E. And for transition of E, again there is no transition from 10 on A. So it will remain same as transition will move to B only. And similarly from 10 there is no new transitions as it is a final state. So we are having C. Okay. So the same C. So when you are taking this, you'll be having B and C. So final DFA is having 5 states A, B, C, D, E over the alphabets small a and B. The D transition table is given here, right? The del transition is given here. And what is the starting state for this DFA? Whichever is having 0 state, that will be the starting state. Only A is having the 0, right? So A is the starting state, right? Which are all final states? What is the final states for DFA? NFA? 10 is a final state. So let us see which are all the states are having 10 as one of these states. A is not having, B is not having, C is not having, D is also not having. Only E is having, right? So we are going to include E as your final state. So this is what we have discussed. A on input symbol A, this is your transition table. Clear? Now you can construct DFA, a transition diagram for this. So this is what the output of subset construction algorithm. Any doubts? You have to draw your DFA table like this, transition table like this, and from this is the input NFA, which is an NFA, and construct this transition table based on subset construction algorithm, and the output is DFA. Okay, so A is the starting state, so let's include as it includes the starting state 0. Similarly, E is the final state as it includes 10 as one of its states. Clear? Any doubts? Can you try this one?